Hello everybody and welcome to this lecture in which we'll take a look at how the programming language Java works. So I expect you to already know what programming is and how we can use it, and I expect you to know what object-oriented programming is. So I will primarily focus on the syntax in Java and the different functionalities it consists of. So why was the programming language Java created? Well, the one who created Java, they had 5 design goals on their mind when they created this language. The first design goal was that they wanted to create a simple language that were object-oriented and familiar to programmers at the time when Java was created. At the time when Java was created, object-oriented programming was very popular, so they wanted Java to be object-oriented as well. And you primarily did object-oriented programming around this time in C++, and they thought that this was a bit complicated, so they wanted Java to do object-oriented programming in a simpler way. They also wanted Java to be familiar to programmers at this time, and since many programmers used C and C++, the syntax that we have in Java is very similar to the syntax that we have in C and in C++. The second design goal they had on their mind was that they wanted Java to be robust and secure. And as a result of this, in Java we have something called the garbage collector. So in Java we don't need to manage the memory in our programs ourselves. Instead we have the garbage collector to do that for us. So the garbage collector is also related to the program language being simpler, but also the programming language being more secure. Because if it's simpler, then it's harder for us programmers to make mistakes and the program is more secure. A third design goal they had is that they wanted Java to be architecture neutral and portable, and as a result of this we have the Java virtual machine. So Java is not really just a programming language, it is an entire platform on which Java programs runs. So I'll come back later and talk more about the garbage collector and the Java virtual machine. They also wanted Java to have high performance, and they wanted Java to be interpreted, threaded and dynamic. So Java is architecture neutral. What does that really mean? Well, first let's take a look at what architecture dependent means. So this is how it works for C and C++ and other programming languages. So the idea is that we write our source code here in, for example, C and C++, and then we want this source code to run on a computer of a specific type that runs a specific operating system. To make this happen, we start by compiling our source code using a compiler, and we compile this to bytecode or machine code that runs on this machine, and then we can run this machine code on the machine. But if a user runs another computer or a computer that runs another operating system, then the machine code we have here cannot run on this computer. So if you want your source code here to run on this computer, then you need to compile the source code again, but for another computer and another operating system. And when you do that, you end up with machine code for this computer and this operating system, and you can then run this machine code on this computer. So this works, but the drawback is that we need to compile our code here multiple times. So if we have 10 different computers here, then we need to compile it 10 different times. And this is something we want to avoid. So Java is architecture neutral, so let's take a look at how they achieve this. So with Java, we will be writing our Java code as our source code, and then we want this Java code to run on computers of different types and possibly different operating system here. So how do we make this happen? Well, the users over here, before they can run our Java program, they need to install something called a Java virtual machine, and the Java virtual machine is what will run our Java code. So the user on this computer need to install Java virtual machine that has been created for this type of computer and that specific operating system. And the user at this computer needs to install a Java virtual machine that has been created for this type of computer with the specific operating system here. Then the users over here should in theory be able to run the Java code we have here, but to speed things up, the Java code we have here, it's not sent directly to these Java virtual machines. Instead, we, the programmer, we first compile the Java code, not into machine code, but into another format called Java bytecode. So this is just another representation of our source code over here. But since this is in compiled format, the Java virtual machines here will be able to read this Java bytecode much faster compared to if they would read our source code over here. But we programmers, we compile our Java code, end up with Java bytecode, and this Java bytecode is what we send to our users, which the users then executes in the Java virtual machines they have on their computers. So this is a little bit more complicated for the users because they first need to install Java virtual machines on their computers. But the benefit here is that we programmers, we just need to compile our source code here once, and then we can send this to all of our users no matter which type of computer they run and no matter which operating system they run. The drawback with this solution is that these virtual machines for different type of computers and different operating systems needs to be created and users need to install them on their computers. Another drawback is that these virtual machines, when they run the Java bytecode, it will run a bit slower compared to machine code. If I remember right, on average it will run 10% slower compared to, for example, machine code we end up when we compile C and C++ code. But this of course depends on the program. That 10% slower is just an average. There exist many different compilers we programmers can use to compile our Java code into Java bytecode. Wikipedia has a list with some of them. So here we have the list of compilers. I think the most commonly used one is Java C, short for Java Compiler, which comes from Sun Microsystems, which was the company that created Java. And they were later bought by the Oracle company. So now Oracle is the ones who owns Java. And the users over here that needs to install a Java virtual machine on their computer, there exist many different Java virtual machines they can choose from. And Wikipedia has a list of these as well. So here we have active Java virtual machines under development. So as you can see, there are many of them, and which I think is the most commonly used one is Hotspot, which is the open source Java virtual machine implementation by Oracle. But any one of these should be able to run Java bytecode. Let me explain what the garbage collector is in Java and how it works. So to do that, I will show you some code in C++ here to the left, and here to the right I will show you the corresponding Java code. So the C++ code we have here, we have a for loop that iterates 100 times, and in each iteration we allocate some memory here to store information about the new circle object. Then here we do some work with the circle object, so in this case call the getRadius method on it. And then we're done using the circle object. And if this is all of the code we have, then we would be leaking memory, because we never give back the memory we allocated here to store the new circle object. So to make this code complete, what we should do at the end here is that we use the delete statement and we give it the pointer to the circle that we created up here. In Java, the code we have here to the left would be implemented like this. So here we have a for loop that iterates 100 times in Java. So this is identical to how we did it in C++, so the syntax is very similar and familiar. To create a new circle object, we use the new operator here, just as over here. Here we would get back a pointer to the new circle object. Here we instead have a reference to the circle object. In Java we don't have pointers in the same way as we do in C++. To call a method on the circle object we have here, we simply write the circle object dot the name of the method. And then when we're done using the circle object, we don't need to do anything special to give back the memory we allocated for it, because this is where the garbage collector comes into the picture. Every now and then, for example 1 time each second, the garbage collector, which is a program in the Java virtual machine, it will run, look through our program and try to find these objects that no longer have any references to them and therefore can't be used anymore. and when it finds one of these objects, then it will free the memory for it. So in Java, we use the new keyword like this, but we never use the delete keyword like this. So here is some extra motivation for you to learn Java. According to the TIOBE Programming Community Index, Java is the most popular or most used programming language out there today. So if you go to their website, we can take a look at this graph. So what the TIOBE Index is about is that they have analyzed the name of programming languages people have searched for using different search engines such as Google and other ones. And their theory is that the more people search for a programming language, the more popular or the more commonly used that programming language is. And according to their finding, Java is the programming language most people search for, and therefore they think Java is the most popular one. So first place Java, then C, then Python, then C++, and so on. So here we have a table with all the information, but if we scroll down, then we get to see this graph instead, and we can see how this changed over the years in 2002. So Java, which is the blue one here, it has always been one of the most popular programming languages during the 21st centuries. It has been challenged here by C, and then we have all the other programming languages here at the bottom. But the difference here is really not that big. So if you're going to learn a new programming language, it doesn't really matter that much that you actually learn Java, because they are kind of equally much used, all of them. So it's more important to be a better programmer instead of knowing a specific programming language. Java is a programming language that is continuously improved, so over time we get new and new versions of it. So let me show you which these different versions are. So the first version of Java, the Java Development Kit 1.0, we got it in 1996. Then in 1997 we got 1.1. Then after this something strange happened. So at this time there was only one Java platform. Then they decided that they wanted to have 3 different Java platforms. So they had an Enterprise Edition, they had a Standard Edition, and they had a Micro Edition. So Standard Edition, this is the platform that runs on ordinary computers. If you want to run Java on an embedded system that has limited resources, then the Standard Edition might be too big for it in order to run Java at all. So for that they have the Micro Edition. So this is a much smaller set than the Standard Edition, so you can do less things with it, but hopefully enough things in order to implement the embedded system you're going to implement. And in addition to these two, we also have the Enterprise Edition, which is for implementing big websites. So since they thought that these were quite a big changes, they changed, so they no longer call it JDK. Instead they started to call it Java 2. And so in 1998 we got Java 2. So here I just show you the Standard Edition, but we got the Enterprise Edition and the Micro Edition as well. So they call it Java 2 Standard Edition and then 1.2 because they increased the version number here. So this is a bit confusing that they have a 2 both here and here. Then in 2000 we got Java 2 Standard Edition 1.3 and we got Java 2 Standard Edition 1.4 and Java 2 Standard Edition 5.0. So here they realized that this naming is really stupid because we will just continue with 1.4, 1.5 and so on. So here they changed the naming, so they say Java 2 Standard Edition 5.0. And now this really confused programmers as well because it says Java 2 but it also says 5.0. So after this, they started to call it Java Standard Edition 6 instead. So they basically dropped the 2 and they dropped the decimal number here as well and just call it Java Standard Edition 6. Then after this, we got Java Standard Edition 7, Java Standard Edition 8, 9, 10, and 11. And each new version of Java adds more features to the language and to the platform Java runs on that we can use. But the important thing here to remember is that when you write Java code, you will write it for one specific Java version. And then when it runs on the user's computer, it will run on a Java virtual machine that supports one specific version of Java as well. So if you write Java code, for example for Java Standard Edition 11 here, and the user is running a Java virtual machine that only supports Java Standard Edition 7, then that user might not be able to run your Java program here, because you're using new feature that Java virtual machine doesn't understand. So when you use Java, you need to think about which version of Java your users will support, and then you use the Java version when you create the program thereafter. But enough with meta information about Java. Let's take a look at the things we need to learn to implement a program in Java, the Hello World program. So the first thing we need to know is that the Java code we write, we'll write it in files, and these files should have the file extension .java to indicate that they contain Java code. In these files, we write code that implements one of the following types, so either a class, an interface, an enumeration, or an annotation. So a class, you probably know what that is, or I expect you to know what that is. An interface is a collection of methods that should be implemented, and then classes can implement an interface by implementing those methods. An enumeration is a collection of values where we can specify which the valid values are. And an annotation is something that we can add to a class, an interface, or an enumeration, or to a method to tell the compiler some information about the class or the interface or enumeration and so on. So we ordinary programmers who create Java program, we don't create our own annotations. Instead, we primarily make use of annotations we get from Java or from some library. This type that we put inside a file, we get to give it a name, and the name we give to the type must match the name of the file. So if we create a Java file called hello.java, then the name of the type inside the file must be hello. The name of these types, they are written like this. So in camel case, with the first letter here capitalized. Our Java program will consist, or most likely will consist of multiple different classes, different interfaces, different enumerations, and so on. And all of these, they are organized in different packages. So if we want to create a new Java program, then we need to start out by creating a new package. So at the top of all our Java files, we will write the package statement to indicate to which package the Java type we have up here belongs to. And the package statement looks like this. So we write package and then the name of the package. And here we use the reverse domain name convention. So the idea is that all Java packages, they have a unique name, and to make sure that all of them are unique, they are based on domain names that you should own. But if you don't own the domain name, as long as you make it unique enough, that is hopefully good enough. And it's also reversed, so instead of having the top domain here at the end, we have it in the beginning, and so on. So where is the entry point? If our program consists of multiple classes, where is the entry point? Well, any class in our package can act as the file containing the main program, because the class that have this method, or a method with signature, that one will be the entry point. So when a user tries to run our package, then the Java virtual machine will look for a class that has a method that looks like this, and then it will call that method. By just using Java, we can't create that useful programs, just programs that carry out computations. But in Java, we have these packages that contains extra functionality. And by importing this extra functionality, we can create more useful programs, programs that read and write to the console, or read and write to files, and things like that. So if we want to do that, then the first thing we need to do is to import that functionality from the corresponding package, and to do that we use the import statement. You can use the import statement in different ways, but here is the most commonly used way you do it. So you write import, then the name of the package, then a dot, then the name of the class, interface annotation, or enumeration that you want to import. Then you only import the thing that you name here. If you want to import everything from a package, then you write import the name of the package and then dot and a star. Java virtual machines out there, they contain some packages by default, and one of these packages is the java.lang package, and we can use functionality in this package to print and read things to the console. The java.lang package is also a bit special because this package is imported by default. So if you want to use any class or interface from this package, we don't need to import it ourselves. If we want to print something to the console, then we can use the system class from this package. So system here is a class, and it has a class variable called out, and here we call the method println on that class variable. So when we do that, we can pass it a value here, then that value would be printed to the console. So let me show you how the documentation here works. So if we click on this link, then we come to the documentation for the java.lang package. So here we have a list with all the interfaces that exist inside this package. Then we have a list with all of the classes. Then we have a list with all of the enumerations, a list with all of the exceptions. And then a list with all of the annotations. But I said that there existed a class called system, so here in the list of all the classes we should be able to find that one. So here we have it, and it says the system class contains several useful fields and methods. Class fields and methods. So we click on this one, then we come to the documentation for this class. And here we have field summary, and we find 3 static fields. We have one called error, short for error, one called in, short for in, one called out. So out, that is an instance of the print string class. So if we want to figure out what we can do with the out, take a look at the print stream documentation. Here we can see that the class print stream, it extends the class called filter output stream, and that it implements the interfaces appendable and closable. Here we have the different constructors that we can use to create new instances of the print stream, but we already have one, so we want to know how can we use a print stream. So we go down to the method summary that lists all the methods. So here we have the different methods that we can call on a print stream. So I showed you before that you can call one method called println and pass it a value. So here we have one println method that receives a Boolean value and prints it, one that receives a character and print it, one that receives an array of characters and print it, and so on. And if we want to print a string, then we would take a look at this method, which receives a string. Here it says print a string and then terminate the line. And we click on this one, we can see more information about the method, and it says print a string and then terminate the line. This method behaves as though it invokes print, passes a string, and then invokes the method println. So quite nice documentation when it comes to Java. So let me show you the code you need to write in order to create a Hello World program. So at the top of our Java file we need to write the package statement, and in this case I use this one as the name of the package. Then the name of the Java file here is called myProgram, so the class here needs to be called myProgram as well. And inside this class we have this public static void main function, which receives an array with strings. So when the user runs our program, it's the code we write here that will be executed. So here we can use system.out.println and pass it hello world like this. So now when we've written the source code for our Hello World program, how can we run it? Well, the first thing we need to do is to compile the Java code we've written in our Java file to bytecode that exists inside a .class file. So this file that we have at the moment, we need to compile it into a file called myclass.class that contains the bytecode. To do this, we can use a command called javac. Then when we have this file that contains the bytecode and we run it in a Java virtual machine, then to do that we can use the Java command. In this case our program only consists of a single file, and then we can do it like this. But if the program would consist of multiple files, then what we can do is that we package all of these files into what is called a jar, a Java archive file. And a Java archive file, that is simply a zip files that contains all of the files that contains the bytecodes. But instead of having the file extension .zip, it usually have the file extension .jar to indicate that it's a Java archive. If you want to package it like this, then you can use the jar command. And programs and libraries, they usually consist of multiple classes and interfaces and so on, so they are usually distributed as jar files. So if you, for example, receives a jar file and you want to run it in a Java virtual machine, then you can use the Java command like this. So let me show you how this can work in practice. So here we create a new directory, we enter it, and then we open it up in Visual Studio Code. And here we create a new file called myprogram.java. And here we paste that hello world code we had before. And to make things a bit simpler, I will remove the package statement. In a real program you should really have it there, but then it's a bit harder to compile and run the program. That is much easier without the package statement. So now we have this file with the source code. Then we go back here and we run the command javac, and we pass it myprogram.java. And if we take a look at which files we have in the directory now, we also have the file called myprogram.class. So to run this one, we use the Java command and we simply write myprogram. And then we can see that the bytecode inside the class file here was executed. So now that you know how you can write Java's code and run it, let's take a closer look at the Java programming language itself and all the features it provides to us. So one of the things we can use in Java are local variables, and these are simply variables that we can use inside constructors and inside methods. To create a new one, you write the statement like this one. Here you specify which data type the variable should be of, then the name, and then an expression here that will be the initial value of this variable. The naming convention in Java for local variables is that we use camel case like this, where the first character here is in lowercase. After you created a variable, you can of course assign it a new value, and for that you use an expression like this one. So which are the different data types our local variables can have? Well, we have something called primitive data types, and here we have a table of all of them. So local variables, they can, among other things, be of these data types. So to store an integer, we have 4 different data types here. We have byte, we have short, we have int and long. And the difference between these are how big integers they can store. So byte consists of 8-bit, and it can store integers between this one and this one. Then short is twice as big, and it can store bigger integers. And then we have int, even bigger, and then we have long, which can store really big ones. So when should you use which one of these 4 if you need to store an integer? Well, the guideline here is to always use int, and then we have some exception to this guideline. So if you have a lot of integers and you know that all of the integers they fit inside 8-bit or inside 16-bit, then instead of using an int, you can use a byte or a short in order to save memory. So if you, for example, have a big array consisting of 1000 integers and all of those integers fits in 8 bits, then you use a byte array instead of an int array. If you need to use long, then you should do that, otherwise stick to int. So only use long if your integers doesn't fit inside these 32 bits. When it comes to decimal values, we have a float data type and a double data type, and the guideline here is to always use the double data type. The exception to this one is that you can use float if you need to save memory again. So if you have a big array of 1000 floats, for example, and you don't need the precision you get with a double, then you can use an array of 1000 floats to save memory. Then we have the char data type consisting of 16 bits, and it represents a single character. That can be created like this. And then we have the Boolean data type, which can store true and false values. So local variables, when you create a new local variable, you always need to give it an initial value. When it comes to classes, which we'll get back to later, the fields in the classes or the instance variables in the class, you don't need to assign them a default value. And if you don't do that, Java will assign them a default value for you. And here you can see which default value that is. In Java we also have some numerical binary operators we can use on numbers. So you probably recognize these. We have addition, subtraction, multiplication, division, and modulus. But what happens if you try to apply these to different data types? Well, this is how it works in Java. If one of the operands to these operations is a double, then the other operand will be converted to a double, and then the operation is carried out and the result will be a double. If one of the operands otherwise is a float, then the other operand will be converted to a float, then the operation is carried out and you obtain a float as a result. Otherwise, if one of the operand is a long, then the other operand is converted to a long, then the operation is carried out and you obtain a new long value. Otherwise, both of the operands are converted into ints. So a few examples of these. So if you have an integer or an int and you try to divide it by an int, you don't end up with a float or a double, you end up with an int. So you just get the integer part of the division. If you have an int and you try to divide it by 0, then Java will throw an exception called arithmetic exception. If you have a decimal number, so a float or a double, and try to divide it by a float or a double, then you obtain a value that represents either positive infinity or negative infinity. If you have a short and you try to add it with a short, then you get an integer or an int as a result. In Java we also have some relational operators, and you probably recognize these as well. And the principle here is the same as for the operators we saw on the previous slide. So as long as both operands to the operator is of same data type, no problem. But if they are different data types, one of the data types will be converted, or at least one of them. So if one operand is double, convert the other one to double. If one of the operand is a float, convert the other one to the float. Otherwise, if one of the operand is long, convert the other one to long. Otherwise, convert both to ints and then carry out the operation. In Java we have some logical operators as well, and these only works on Boolean values, so they only work on true and false. Here we have the three most commonly used ones. We have the not operator, which is implemented as an exclamation mark, and then we have an expression for the operand here. So this one negates this value. We have the or expression, which is implemented as these two characters. So either this operand should be true or that operand should be true. And then we have the and operator implemented as these two characters. So this one should be true and this one should be true. Both the or operator and the and operator, they are evaluated in a lazy way. So what that means is that Java will start by evaluating the first operand here, and in the case of the or operation, if the first operand here evaluates to true, then Java knows that the entire or operation here will evaluate to true, so Java doesn't care about evaluating the second expression here at all. And similar for the and expression, Java will start by evaluating the first operand here, and if that one evaluates to false, then Java knows that the entire and expression here will evaluate to false. so Java doesn't care about evaluating the second operand here at all. In addition to these three, we have other operators as well. For example, we have the bitwise OR operator, which is implemented as just one of these characters instead of two of them. And we have the bitwise AND operator, which is implemented as one of these characters instead of two of them. So in your code, if you wanted to use the OR operator or the AND operator, but you just type one of these characters, then your code is still valid, it will still compile, but it might not work the way you want it. So if you make use of the OR and the AND operator, make sure that you write two of these symbols. We also have the if statements, and these works just as in C and in C++ and similar. You can write an if statement like this, and to an if statement you can add an else statement at the end. And between the if statement and the else statement you can add as many else if statements as you want. We have a while loop in Java that looks like this, so just as in C and in C++. We also have the do while loop that looks like this. So the difference between the while loop and the do while loop is that the do while loop, it will always execute the body here at least once. We also have the for loop, and it works very similar to how it works in C and C++. So we have an initialization part here, we have a condition, and we have a change part that should change something each iteration. And for loops in Java, we write them kind of the same way as in C and C++. The iteration variable, usually called I, and the data type for it is usually an int. To create a new array in Java, you write the statement like this one. So here you specify the data type, and then square brackets, then the name of the variable, then equal, and then the new operator, then the name of the data type again, then square brackets, and an expression here that should evaluate to an integer that represents how many elements the array should store. Then all of the values you put inside this array must be of the data type that you specified. The first index in the array is 0, and then incremented by 1 as usual. To retrieve an element at a certain position, you write an expression like this one. And if you want to update a value at a certain position, you write the statement like this one. And arrays in Java, they have a special property or field called length, and you can use this one to obtain how many elements the array consists of. So in C and C++, you typically need to use an additional variable to keep track of how many elements the array consists of. But in Java, we don't need to have this because we can obtain that by using the length property of the array instead. So here is a short example of a program making use of array. So we have our class here that contains our entry method. And inside this one, we start out by creating a new array here that stores 3 int. And since we haven't specified which 3 int that should be, all 3 ints will be set to 0 by Java. Then here we change the first integer in the array to 3, and the second one to 1, and the third one to 4. And here we obtain all of those values, compute the sum, and then we print the sum down here. But instead of doing it the way we did it before, we can use a loop to iterate over the indexes in the array and then access the value for each index and add it to a sum variable. So here instead we have a sum variable starting on 0, then we have a for loop to iterate over all the indexes in the array. And for each index we obtain the value at that index and we add it to the sum variable. And then we print what is stored in the sum variable. In the example before, we initialized the array like this, but Java provides us with a more convenient way to do it. So with an expression that looks like this one, we create an array and we specify how many values it should contain and which those values are here immediately when we create the entire array. In Java, we also have a loop called enhanced for loop, and it is a better way to iterate over values in arrays and in collections. And a collection in Java, that is any class that implements the interface called iterable of a specific data type. When we use the enhanced for loop, we don't iterate over the indexes in the array or in the collection. Instead, we iterate over the values. The syntax for an enhanced for loop looks like this. So we write for, so it's still a for loop, but between the parentheses here, it looks a bit different. So here we write an expression that should evaluate to the array or the collection. Then we have this colon here. Then we have the iteration variable and the data type of this variable. And then we have the statements here in the body as before. So back to the example we had before here to the left. But now when we know that we can create an array and initialize it at the same time, then instead of writing these 4 lines of code, we just need to write this single line of code. And down here we iterated over the indexes in the array, and this is not that readable code. But what we can do instead is that we use the enhanced for loop to iterate over the values in the array directly. Then the code we have here to the right becomes much more readable than the code we had here on the left. Let's continue with classes, and the first thing you need to know when you are about to create a new class is that you need to specify which visibility the class should have, and this sets restriction on who may use the class. So the syntax for creating a new class looks like this. You write class, then the name of the class, and then the constructor and methods here inside the class. Here you get to specify the visibility the class should have. And you have 2 options for visibility here. A class can either be public or it can be default. So if you write public here, then it's a public class. If you don't write anything, so you don't write any visibility at all, then the visibility becomes the default visibility. And if it's public, then anyone can use this class. Other classes inside your own package can use the class, but also classes inside other packages can use the class as well. If you don't write public here, but doesn't write anything at all, then it's only the classes inside your own package that may use this class. So if you create a package that you plan on distributing to other programmers so they can use it in their own program, then you should write public here in order for them to be able to use your class in their own programs. Just as a class has a visibility, members inside a class has visibility as well. And with members inside a class, I'm talking about fields, constructors, method, and nested types, such as an inner class or an inner interface. So to specify which visibility a field should have, you write the name of the field, then the data type, and then here the first thing is the visibility. And for a constructor, you add a constructor like this, so a method with the same name as the class, and you add the visibility before the method name. And for methods, you have the name of the method, the data type the method returns, and the visibility. And as an example of a nested inner class, you write the name of the inner class here with the class keyword, and then the visibility here. So what are the different visibilities we can use for our members? Well, we have 4 different options: public, protected, and private. So just as with classes, public means that anyone is able to access this member. And the opposite of that one is private. If you use the visibility private, then it's only the class itself that have access to that member. If you don't give the member any visibility at all, so you don't write anything at all here, for example, then it becomes the default visibility. Then it's only classes inside your own package, and of course this class itself, which belongs to its own package, that can access that member. If you write the keyword protected as the visibility, then all classes inside the same package can access that member, but also subclasses in other packages can access that member as well. So imagine that we have this class inside this package, then we send this package to another programmer. That other programmer writes his own code in another package, and he creates a subclass, so a class that inherits from this class. Then he can access all of the members here that has been marked as protected. So let me show you an example of a class, and in this case we will implement a counter class, so a class that represents a counter that can be incremented. So to do this, we have a public class which we call counter, and it has an instance variable called value, which we use to keep track of how much the counter is on. And this one is private and of a type integer. Then we add a constructor, and the one who creates a new instance of the counter class gets to specify what the counter should start on. So inside the constructor here, we say that the instance variable value should be equal the value we receive here through the parameter. Then we have one method called increment. So when someone wants to increment the counter here, call this method and pass it an integer here that represents the amount it should be incremented. And we have another method called getValue to get the value the counter is currently on. So the one who makes use of this class, it can use it like this over here. So here they create a new instance of the counter class, specify it should start on 5, then specify that it should be incremented by 3, and then we get that value of the counter and we print it. In some object-oriented programming languages, we have a special variable called this that we can use inside methods and inside constructors. We can do that in Java as well, but it's usually not necessary to use it. So in Java, inside constructor, we can use the special variable this to refer to the new object that is being created, and inside methods we can use the special variable this to refer to the object to call the method. But most often we don't need it, because if you use a name inside a method or inside a constructor, and that name can't refer to anything else but the member inside the class, then Java will presume that it does refer to that member inside the class. But if that's not the case, if the name can refer to something else, then you need to make use of this special variable this. So here is an example of how we can make use of the this variable. So here we have the class as we had it before, but if we would implement it like this instead. So here we called the parameter here start value. So inside this constructor we can use value to refer to the instance variable value here. But in this case we call the parameter for value, and the instance variable is called value as well. So if we use value inside this constructor, then it would refer to this parameter. So if we want to assign this variable the value from this one, then we would in this case have to say this.value equal value. In this method, value, the only thing it can refer to here is this instance variable. So here we don't need to write this.value. But if you want, you can write this.value here instead as well. And the same is true down here. You can write this.value if you want to, but since value can't refer to anything else but this one, just writing value is fine as well. Classes in Java, they support something called method overloading, and what that is that different methods in the same class, they can have the same name, but their parameter list must somehow be different. So different amount of parameters or different type on the parameters. This is not only valid for methods, it is valid for constructors as well. And inside a constructor, if you want to call another constructor inside a class, then you can call the other constructor by using the special this variable, like this. So Java doesn't support default values for parameters, but by using method overloading we can achieve something similar. Let me show you an example of this. So here we have a constructor that receives an integer as argument. But what if we want this one to have a default value? Well, what we do then is that we use method overloading. So here we have a constructor that doesn't receive any arguments at all. And the thing this constructor does is that it calls the constructor up here with a default value for this parameter. So down here we make use of the class we have up here. So we can create a new instance of the class like this, passing 1, then the constructor up here is called. And we can also create a new instance of the class like this. Then this constructor is called, which then immediately calls this constructor. All classes in Java need to have at least one constructor, and you need to write the code for this even if the constructor doesn't do anything useful. Or actually, you don't need to write the code for it, but if you don't write any constructor at all, then Java will write one for you. And this constructor Java will create for you, it is a constructor that is called the default constructor, and it is simply a constructor with no parameters at all, and it doesn't do anything useful. But the point is that all classes have at least one constructor. A class in Java must inherit from one other class and only one other class. There exists one exception to this one, and that is a special class called the object class. That class doesn't inherit from any other class, but otherwise all other classes will do. If you create a class and you don't specify which class you want to inherit from, then Java presumes that you will inherit from the object class. So all classes in Java, they inherit from the object class either directly or indirectly. When you create a class, you specify which class you want to inherit from. So here we create a class called myClass, and we inherit from the superclass. Inside our class, we can use a special keyword called super to refer to the superclass, the class we inherit from. Inside constructor, if we want to call a constructor in the class we inherit from, then we use the super keyword like this. And inside a method, if we want to call a method inside the class we inherit from, then we call the method in that class like this. Constructors are not explicitly inherited. So what I mean by this is that if we create a base class that inherits from a superclass, then in our base class we can call the constructors in the superclass as expected. But if a user creates a new instance of our base class, they must do so through constructors in the base class. They can't use the constructors in the superclass. And in the constructor in our base class, we must call a constructor in the superclass. And if we don't do this, then Java will do it for us, and it will call the default constructor in the superclass. So let me show you an example of inheritance. So here to the left we will have the superclass, and here to the right we'll have the base class. So the superclass is called class A, and it has an instance variable, the number. It has a constructor here that receives a number, and it assigns the number a number. And then we have this method here to do some work with the number up here. And then here to the right we have the base class, which inherits from the superclass, class A here. So with the code we have now, if we would try to compile this, then we would get a compilation error. And even if we add a default constructor here, we would still get the compilation error. We would get the same error as with just this code. And the problem is that if we try to compile this as it is now, then we haven't written a constructor here. So Java will write one for us. It will write the default constructor, this one, that doesn't do anything. But the first thing that will happen inside this constructor is that Java will call a constructor in the superclass. And since we haven't specified which constructor in the superclass to call, it will call the default constructor in the superclass. But over here in the superclass, we had a constructor, and it receives a parameter here. So this constructor is not the default constructor. And since this class has a constructor, Java will not write the default constructor for us. So if we try to compile this code, we will get an error that this class doesn't have a default constructor. So inside this constructor, we need to call a constructor in the superclass. And since it only have this constructor, we must call this one. Then here we have a method with the same name as over here. And in this case, we want to call the method over here. So we write super.getNumber to call this method. We get back a value, and then we add that with the term we receive here and return back. And when we override a method like this, then we should also use an annotation called @override. What we do with this annotation is that we tell the compiler that we are overriding the method we have over here on purpose. Imagine that the superclass here contains 100 different methods. Then when we add a new method to our own class here, we might by accident name that method the same name that the method has over here. But by adding the override annotation here, we tell the compiler that, hey, we are overriding this specific method on purpose. Then if we add a method here that on accident has the same name as over here, then the compiler will give us a warning that says that there exists a method in the superclass with the same name that you're overriding. But here we simply tell the compiler that we override it on purpose. Java supports abstract methods and classes. an abstract method is simply a method that hasn't been implemented, and an abstract class is a class that contains abstract methods. To make something abstract, we use the keyword abstract. So if you want to make a method abstract, then when you specify the method like this, then you add the abstract keyword here. But instead of using curly brackets here at the end to actually implement the method, you just write semicolon. To make a class abstract, you add the abstract keyword to the class before the class keyword here when you create it. And then inside this class you can add abstract methods. But once you've done this, you can't create new instances of this class. Instead, what someone needs to do is to create other classes that inherits from this class and then implement these abstract methods. Then these other classes can be instantiated. Java doesn't support that one class inherits from multiple other classes. Instead, in Java, one class must inherit from one other class. But sometimes it makes sense to let a class inherit from multiple other classes. For example, imagine that you need to represent a smartphone, and we want to be able to view the smartphone both as an ordinary computer and as a cell phone. Then it will make sense to create one class to represent computer, another class to represent cell phone, and then you create the third class, the smartphone class, which inherits from both the computer class and the cell phone class. But in Java we can't do it like this, but Java gives us something called interfaces instead. And an interface is simply a collection of public abstract methods, which a class then can implement. And in newer versions of Java, an interface can also contain static methods and default methods, but I will not go through those stuff. So after you created an interface, you can create a class that implements the abstract methods in an interface like this. So public class, the name of the class, implement, and then this interface and this interface. And if you want, you can implement more interfaces by separating them by comma. Then of course inside your class you need to implement all the abstract methods inside these interfaces. So here we can, for example, create one interface that specify how a computer should work, one interface that specify how a cell phone should work. Then we create one class to represent a smartphone. Then inside this smartphone class we need to implement these two interfaces. But this way we can see the smartphone class as a computer, and we can also see it as a cell phone. So here an example in Java that makes use of interfaces. So here we create one interface called simple calculator, and it contains one abstract method which is called add, and it receives a number. Here we have another interface called complex calculator, which has a method called multiply, and it receives a number as well. Then over here we create a class which we call calculator, which implement these two interfaces. So this calculator class, it can be seen as a simple calculator, and it can also be seen as a complex calculator at the same time. Here we have an instance variable to keep track of what is stored inside the memory in the calculator. Then we have the constructor, we simply set this one to 0. Then here we implement the add method from the simple calculator interface. And since we override an abstract method, we have this override annotation again. So here we simply say that the memory variable plus equal number, and then we implement the multiply method from this interface. And here of course we say memory variable multiply times equal number. Exceptions in Java are implemented as classes, and if you want to throw a new exception, then you write the statement like this one, throw, and then an expression here that should evaluate to the exception to be thrown. To create a new exception, you create a class that inherits from the class throwable. You can do it like that, but more commonly you create a class that inherits from the class exception, which in turn inherits from throwable. If a method in a class can throw an exception, then you should specify that when you create the method. So after you've written the name of the method and the parameter list here, you write throws, and then the name of all the possible exception this method can throw. If your exception that can be thrown, instead of inheriting from exception, you inherit from runnable exception, then you don't need to specify that exception here. If you want to catch an exception, then you can do that with a try statement and a catch statement and a finally statement. So let me show you an example of how you can create your own exception class and how you can catch exceptions that are thrown. So to create your own exception class, simply create a class that inherits from the exception class, and then you need to add a constructor, for example the one that receives a string as its argument, and then you simply pass that one to a constructor in the exception class. Then in your code over here, where you might have some code that throws an exception, you put that code inside a try statement, and here we call this imaginary method, which might throw an exception, and we want to figure out is an exception thrown or not. If an exception is thrown that is an instance of the class myException, then it will be caught here inside the catch statement we have. So here we write code that handles that exception. And here we can, for example, use the getMessage method on the exception in order to get the message that we received here when we created the new instance of the myException class. If this method might throw exceptions of multiple different classes, then we can continue listing more catch statements here. So here we specify that if an exception is thrown, which is an instance of this class, then the code we have here should run. And here we see another method that is quite useful when it comes to exceptions, the e.printStackTrace method. It prints all the call chains to where the exception was thrown. So this is useful for debugging. And then after the last catch statement, you can add a finally statement that always runs. So the idea is that inside the try statement, you try to build up something, and that might throw an exception. Then you handle the exception in these different catches. And then here in finally, you write code that tears down the thing you build up inside the try statement here. So the code inside the try statement, it will always run. All of it will run down to until the first exception is thrown. Then in the catch statement, only one of them will run, and the one that corresponds to the exception that was thrown. And then the code inside the final statement here, it will always run afterwards. Java supports something called generic classes, and a generic class is simply a class where data type hasn't been hard-coded inside the class. Instead, it's the one who creates new instances of the class that can specify which data types that should be used inside the class. If you want to create your own generic class, then you do it like this. After the name of the class here, you write angle brackets, and between them you specify a type parameter. Then in the implementation of your class here, instead of hard coding a data type, you simply refer to this type parameter. Then the one who creates new instances of this class can specify which type parameter to use. And to do that, the one who creates new instances of the class do it like this. So here we specify the class name, and then between the angle brackets here, we specify which data type to use inside the class. And then create a new instance of it like this. And here to the right, if you want, you can specify a class here as well, but you don't have to do that anymore in Java. You had to do it before, but then in the new version of Java, they added a feature you don't need to repeat the same name of the class here and here. Generic classes, they are typically used for collections, so classes that are built for containing objects of some kind. For example, in Java, we have a list class or an array list class, which works as a list that stores other objects. So if we want to create a new array list, then we need to tell Java which other type of objects it will store. So in this case, we specify that it will store objects that are of this data type. So after we created our list here, then we can call the add method on the list and pass it new instances of the my class. So let me show you an example of how you can make use of a generic class. So first we create a class here that represents a human, and the human has an age, and then we add a constructor to the human where we simply receive an age and we set it to that instance variable. Then over here we create our main program, and here we create a new array list which should store humans inside these local variable humans. Then after we've done that, we can create a new human object and we add it to the list. Here we create another human object, we add it to the list. By calling the get method, we retrieve the human at index 1 from the list. By calling remove method, we remove the human at index 0 in the list. And by calling the remove method, we can also pass it a human object directly to remove that one. Here is another example of how we can create our own generic class. So here we create a class called pair, which should be able to use to remember two values. The first one should be of the data type T1 and the second one should be of the data type T2. So here we have an instance variable of type T1 and an instance variable of type T2. Here we have a constructor that receives a value of type T1 and a value of type T2. And then we remember these values in these two instance variables. Then down here we have one method to retrieve back the value of the first one. So return type of this method is T1 and something similar for the second one. So the return type here is T2. If you then want to make use of this class, then over here you create a new instance of the class, and here we specify that the type of the first one should be an instance of class A and the type of the second one should be an instance of class B. Then here we can write p.get1 to get the instance of the first one, and we can write p.get2 to get the instance of the second one. The type parameters in generic classes, they can't be primitive data types such as int or float. So if you want to create an array list, for example, that stores integers, then you can't use int as the data type for it. But each primitive data type in Java, they have a corresponding class which is used to only store one instance of that primitive data type. So for example, the primitive data type int, there exists a corresponding class for it called integer, and the only thing this class does is that it stores an int value. And in a similar way, the primitive data type double, there exists a corresponding class for it called double, and the only thing this class does is that it stores an instance of a double. And similar for the other data types. So if you want to use a generic class and make it store a primitive values for you, then you need to encapsulate those primitive values inside their corresponding classes. So let me show you an example of this. So imagine that pair class we created before, we want it to store an int value and we want it to store a double value. To make that happen, then we specify that it should store an integer object and a double object. Then instead of passing it directly 20 and 2.32, we take this 20 and we create a new integer instance that stores that 20 value and the corresponding thing for the double value. Then when we say p.get1, then we get the integer object, and to retrieve 20 from that integer object, we call the int value method on it. And for the double object, when we say p.get2, then we get this double object, and to get the double value from it, we call the double value method. However, in Java 5 we got two new features that made this a little bit easier. So the first one is called out-of-boxing, and with this one, when we have a primitive value but we actually needed to use a corresponding object instead, then we can still write that primitive value and Java will automatically create this corresponding object for us and put the primitive value inside of that object. And in the same way, we also have unboxing. So if we get an object that contains a primitive value, then Java will automatically take out the primitive value from that corresponding object. So from Java 5.0 and on, we don't need to do it the way I showed you 2 slides ago. Instead, we can do it like this. So here, the pair constructor here, it expects us to pass 2 objects, but since we use primitive values here instead, then Java will here automatically create a new integer object and put 20 inside of it, and here it will create a new double object and put 2.32 inside of it. And then here, when we call p.get1, we actually get back that integer object that Java created for us here. But Java will see that we expect to get an int value here, so it will automatically unbox this integer object for us. And it's the same thing with a double down here. Java also supports downcasting, so let me show you an example of this. So imagine that we have one class here called class A, and then we have two other classes here. The first one is class B, which inherits from class A, and inside class B we have an instance variable called B1. And then down here we have class B2, which also inherits from class A, and here we have an instance variable called B2 instead. And in our main code here, we should implement this function where we receive a list that contains class A objects. Now, since the class A class here is abstract, then we know that the objects inside this list, they will not be instances of this class directly. Instead, they must be instances of either this class or this class, because these two are the only two classes that inherits from this class. And what we should do inside this function here is that we should summarize all of the values in our objects. So if the object is an instance of class B1, then we should take the value in the B1 instance variable and add it to the sum. And if the object is an instance of class B2, then we should take the integer value here in the B2 instance variable and add that one to the sum. So here we start with a sum variable starting on 0. Then we use an enhanced for loop here to iterate over all the objects in the list we received. So here we need to figure out, should we take the B1 instance variable and add it to the sum, or should we take the B2 instance variable and add it to the sum? And that depends on if the thing we're iterating over, if that one is an instance of the class B1 or if it's an instance of the class B2. So here we can use the instance of operator to check if thing is an instance of class B1. And if it is that, then we write code like this to downcast the thing into the class B1. So up here, the thing, we see it as an instance of class A. So we can only do things with it that is specified or defined inside class A. But since B1 and B2, they are defined in the subclass instead, so we can't access them when we see the object as an instance of class A. But here we downcast the thing to the class B1, which we call T, and then we can access B1 from that T variable. And if thing is not an instance of class B1, well, then it has to be an instance of class B2, and in that case we downcast it to the class B2 class. And we add B2 to the sum, and then we return it here. Sometimes downcasting is really useful, but if you can avoid it, it is better to avoid it. Because otherwise your code will contain a lot of different if statements that says if the object is an instance of that, then we do this. Otherwise, if the object is an instance of that, then we do that, and so on. So if possible, try to avoid downcasting. And one way to avoid downcasting is by making use of polymorphism. So here to the right we have the code that we had before. But if we make use of polymorphism, then the code we write here can look much better. So what we can do is that inside our abstract class here, we add an abstract method called int, and then all of these classes that inherit from class A gets to implement this method to return the integer they should return. So in class B1 here, where we should return the value of the instance variable B1, then we implement the getInt method like this. And in class B2, then we implement the getInt method like this. So we return B2. Then over here, where the thing we're iterating over, we can still see it as an instance of class A, and that one has this getInt method. So even though that getInt method is implemented in the subclasses, we can still call that method when we see the object as an instance of class A. So here we can simply call the getInt method on the thing and we add it to the sum variable. Before I show you the primitive data types in Java, and that didn't include strings. So strings in Java, they are implemented as a class, and this class is called a string class, and it comes from the java.lang package. So it's imported in all programs by default. Strings in Java, they can be created using double quotes like this. So each time Java comes across an expression that looks like this, it will create a new instance of this string class to represent the string. And strings in Java, they are immutable, so after you created a string, you can't make changes to it. But you can use it to create new strings from it. For example, you can use the plus operator to concatenate two different strings to a new string. So here we have a string, and we concatenate it with this string, and we end up with this string. When you have a string like this and you concatenate it with a value, then you can concatenate it with any other value. If that other value isn't a string, then the toString method will be called on that other value. So if the other value is an object, the toString method is called on it directly. If it's not an object, if it's for example an int, then a new integer instance will be created that contains the int, and then the toString method will be called on that integer instance. One of the weirdest thing in Java is that when you compare strings, you shouldn't use the equal operator, because when you use the equal operator and for two different objects, then you check if those two different objects actually are one and the same objects. You don't check if they look the same. So if you have one string here that only contains the character A, and you say equal another string here that only contains the character A, then the equal operator will give you false because you actually have two different things. Instead, if you want to check if two strings contains the same characters, then you should use the equal methods on the string instead. So let me show you an example of using this equal operator with strings, because it is a bit confusing. So here in Visual Studio Code, I've written some code. So here we check if this string is equal to this string, and if they are, we print they are the same, and if they are not, we print they are not the same. So in this case we should get they are not the same, because here we have two different strings and we compare them using the equal operator. So let's compile this code with javac and then run it with Java. Wait for it, there we go. So as we can see here, it's print they are the same, and that is not what we expected, because we have one string object here and another string object here, and they are not one and the same objects. However, what we see here is an optimization done by the compiler. When it reads through the code, it will add all the strings to a string pool, and if the string is already in the pool, then instead of creating a new string object, it will just reuse the existing one. But if we try to make this code a bit more complicated, so if we say like this, 0 and 1. So now the compiler will add this to the string pool, and it will add this to the string pool. Then when the code runs, what we do here is that we call substring method on this one, which retrieves back a new string starting on index 0, so this A, and end at index 1, but index 1 is not included. So what this guy should evaluate to is a new string that only contains the A character. And now we will actually have two different strings that contains the A character. So in this case we should get back they are not the same. So if we compile this code now and we run it, we can see that we get they are not the same. So instead of using this equal operator when you compare string, you should call the equals method on one of the strings, and you pass it the other string as an argument to it. So even though we have one string object here and another string object here that should be equal or identical, in this case we do get back true, so we should see this text on the screen now. They are the same. So we go back here, compile the code, run the code, and we see they are the same. Using the static keyword in Java, we can add members to a class that are static, so they are not part of objects that are instances of the class. Instead, they are rather part of the class directly. So here we have a class called counter, and inside this one we have a static instance variable called value. And since it's static, it's rather not an instance variable, instead it's a class variable. So when you create a new instance of the counter class, that new object you get back will not have a value variable. Instead, this one is only part of the class. By using the static keyword here, we're creating a static method as well. So this method inside this method, we cannot access instance variable of the class. Instead, we can only access class variables. So the variables here that are static. And here we have another method as well. So if you want to use these static members, then you don't need to create a new instance of the class. Instead, if you want to call a method on it, you can do it like this directly without creating a new instance of the class. And since this class variable here, value, is private, over here we couldn't of course write counter.value. Instead, we need to work with this value variable through this public static methods instead. It is good if you can avoid using the static keyword, because often it is more useful to use objects that contains instance variables instead of classes that contains class variables. Because objects, we can easily pass them around in different methods. We can't easily pass around a class to another method. So often objects are more useful that way. But there are some cases where using the static keyword is useful, and here I will show you one of them. So here we have a class that has an instance variable, but it also has a nested inner class here. And this is not that good, because this inner class, it has access to the instance variable of my class here. Now that might be useful, but it will make it a bit harder to run our code, or it will take more computational power. Because the problem here is that each time we create a new instance of this class, what Java will do is that it creates a new class here to represent the inner class. So if we have the code here and create 3 instances of my class, then in total we have 4 different classes. We have my class, and then we have 3 different versions of my inner class too. So that is quite bad. But if we instead make the inner class static, then this inner class can't access the instance variable up here. Then Java doesn't need to create different versions of this inner class each time we create a new instance of this class. So always when you have nested classes or an inner class like this, try to make that class static. Using the static keyword, it is also possible to execute some arbitrary code, and this is useful to initialize some class variables. So let me show you an example of that. So here we have a static class variable, which is an array list that should store integers. And to create that array list, we do it like this. But maybe we want this array list to also contain some numbers initially. Then what we can do is that we use the static keyword like this, and then here we write the code that initializes that array list. So we add the integers 1, 2, and 3. And we also have enums in Java, and this is how we use them. So here we create a new enum with the name day, and this one can have the value either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. Then here we have a sample program that makes use of the enum. So here we specify that the data type of this variable should be day, because that's what we call the enum, and the initial value of this one should be Saturday. And here we check if the day is Monday, and if that's the case, then we write time to work.